This is a test for a 3D pathfinding system that I am working on. So the first step to creating this is to create the overall volume of points in space. And these points will help the enemy AI actually pathfind. So you can adjust the volume size here with your X, Y, and Z, as well as pick the volume spacing. So right here we have a volume spacing of 0.8, and if I were to show our ground nodes, you'll see that each node is 0.8 meters in width and height. And we can change that just here, go to 1 and regenerate the volume at the bottom, and it'll be less accurate, but it will be more efficient, so it just depends on your use case there, on how accurate you need it to be. Now, when generating the volume, you have three volume node types. Here you can see your ground nodes. You can also have air nodes, which we can change to a points view, and you'll see that a bit better, but it's a bit more laggy showing points in space. So the gray is air. The reason for that would be to have the ability to, say, vault over these small objects potentially. Otherwise, you can also hit generate all air, and that will generate the entire volume worth of air, which would be useful for space and any air movement essentially, but would take up a lot more computational resources. So instead, we can just generate a slight layer above the ground nodes, which we can change the amount by changing the air padding here. And the third node type would be the collision nodes. This will tell your enemy AI or any AI agent, don't go in that area. So if we go back to a grid view here and put it on all, you can kind of see them working together there. Let's go no distance of 5 so you can see that a bit better. And you can define your ground layer by picking out of a layer mask here. So any object that an AI agent needs to be able to walk on needs to have a layer for ground. And with that in mind, when you have your exact spacing, you can just generate the volume, and then when we hit play, we'll see that the AI agents are moving along in that new path. Now, our agents themselves will have their own enemy agent script. In this one, you can define the movement speed and rotation speed, as well as some collision detection for the ground. And we can show their path as a debug step so you can see how the system works. And this is using a bidirectional A-star algorithm, so it should hopefully be more efficient than a normal A-star algorithm, but using essentially the same logic. And you can see here that our agents can move diagonally as well, so they have all 26 methods of movement. So if we go back down here and we can see our grid, let's just pick we can pick all available for now. So you can see each point in space, and we take this one here for example, the AI agent can move diagonally this way, back, forward, sideways, but it can also move up vertically and vertically diagonal as well. It has more cost going diagonal, so it should pick a straight line if there is an available one, but being able to go diagonal allows it to go down and up ramps and stairs. So with these agents as well, these agents will have, as a part of this enemy agent script, it has a patrol radius and a chase radius. The patrol radius right now is determined by the spawn point of that agent. So this agent here is spawned right here, which means that it has a radius of 10 meters in all directions. And it will not go outside of that range unless it is chasing the player, and that is determined by if the player enters the chase radius, essentially. Now, the volume, the way the volumes work is agents will find their closest volume to them on play. So what that means is we can actually grab the volume, our environment, and our enemy agents, and if we zoom all the way out, we can duplicate this over here, and all we'll have to do is regenerate the volume, and that will move all the nodes over to the correct spot in world space, and this should mean that your enemy agents can essentially work in 2 separate zones. So right now this has a dedicated, I guess, arena of sorts. However, you can also have, let's just turn that on none. You can have it for, say, individual rooms inside of one big building. Your agents right now are not able to go between them, so you won't be able to have them go into hallways if you have separate ones. You can see here the agents are working, and over on this one, the agents are also working perfectly fine. Now, there are ways to optimize this better, and I will continue to work on that. The most important one, I think, would be to make it a bit more dynamic, because right now, as you can see by going to, we'll go for all the ground nodes only. We'll pick a node distance of 50 in grid form. It's the same density, essentially. So if there's areas like here where it's really flat, same density of nodes. I think that's potentially good. It allows the agents to smoothly go around, but also takes a lot more resources. So I think there's a way to optimize it so that the agents can still move freely in the space, but we don't need this much density unless it's actually around objects, so that we can actually have the nodes as close as possible to the objects, so there's as much movement space as possible. And the other optimization, I think, would be actually just having the agents be able to move a bit more freely. I think adding a randomness variable and a smoothing script should help with that, because right now, if we hit show path on this agent, and we'll give it a patrol radius of 30, we should see that the agent's path is a straight line to the next node. So that is not what I wanted. Let me go to this volume and find that agent, this one. So we can see that path there. The agent's moving very sharply between each node. So I think adding a smooth value as will help make that look nice, as well as adding a randomness so it doesn't look like they're going in exactly the direction they should. They have a slight swerve to them, I think would be better. But that's the pathfinding system as it is right now. Let me know your thoughts, and I will see how I can improve it over time.